For climate change, satellite data are absolutely critical. The observations which are needed for climate change are organized through a body called the Global Climate Observing System, GCOS. That has developed over the last 10 years or so a suite of variables called essential climate variables. And these are a compendium of the most important facets of the planet which we need to observe and understand in order to understand and adapt to and mitigate climate change. There are about 50 of these variables altogether, looking at the atmosphere, the ocean, and the land surface. Of the 50, something like 50%, half of those can only be observed from space. And of the remaining 50%, about half of those again are substantially observed from space with additional measurements being made on the ground. So around 60, 70% or so, 80% of these variables are essentially observable primarily or only by satellite data. So that tells you immediately just how important satellites are in providing us the information we need for climate. And that's for climate prediction and modeling, but also for looking now into adaptation. How do we deal with climate change? Mitigation, how do we minimize the amount of change which is taking place? How do we reduce our emissions? How can we do that through processes like RED, through better agricultural practices? How can we use the information that we have in order to mitigate the problem into the future? We're looking into the future now to see how best we can sustain that in a long-term basis. We developed in the European Space Agency an initiative called the Climate Change Initiative, and we have a climate office which was set up at Harwell in order to manage that program. And that has selected a subset of these 50 ECVs which are particularly relevant for ESA data. And we're developing long-term time series of these data using not only ESA data but data from all other sources. But that gives us the long-term continuity and quality control of those variables, because we're looking at very precise measurements, very subtle measurements of how the Earth behaves. And we need to make sure that when we have these long-term time series, we're not seeing changes in the way that we make the observations reflected in apparent changes in the Earth system. So it has to be very carefully calibrated, very carefully validated against in-situ measurements so we can see what's happening. While we're still considering ECVs as being divided into essentially the old Aristotelian divisions of earth, air, fire, water, so we have ones for the atmosphere, ones for the ocean, one for the land, we're also looking at how they relate to different systems that they're relevant to. So how do different combinations of these ECVs operate within the water cycle, within the energy cycle, within the carbon cycle on the Earth system? How do they relate to the megatrends which we see in Earth development today, the nexus of food, water and energy, developments in agriculture, developments in urbanization? How are they going to change air quality in the cities? How can we measure that? How can we use that information also to make long-term sustainable decisions?